Alright, segment AC is congruent to segment DF, segment BC is congruent to segment EF, angle A is congruent to angle D, and angle C is congruent to angle F. The measure of angle B is equal to 62.3 degrees. The measure of angle E is equal to 62.3. Segment AB is a rotation of segment DE. Prove that triangle ABC is congruent to triangle DEF. So again, if I didn't know what congruent triangles meant, it means that triangles in which corresponding angles and sides are congruent. So corresponding angles are listed in order. So angle A, see how it has the 1 tick mark? Since D is the first vertex listed, that's its corresponding angle, and it also has 1 tick mark. That's also a clue on how to read symbols in math to know which ones are lining up to each other. So angle F's corresponding angle would be angle C. We have to prove that those two angles are the same. It's actually given, and that's why it is marked that way. Notice that angle A is congruent to angle D. That is also given, and that is why it's marked that way. They also indicated the side lengths that were given. So angle C's corresponding side length is angle F, right there, and angle side length CB's corresponding side length, notice it has 2 tick marks, so its corresponding side is going to be 2 tick marked. So I'm looking and I'm noticing, okay, we have one angle that wasn't marked with its corresponding angle. However, it was given that they had the same degree measure. So now it's just a matter of using the definition of congruence to prove that. And then also that segment AB is a rotation of segment DE. It would be good to know and to remember what rotation preserves. So if you don't have that in your notes, I would Google it, and I would just type in when a segment is rotated, what does it preserve? So a rotation maps a line to a line, array to array, a segment to a segment. So what do rotations preserve? Preserves the orientation. It also preserves, I'm going to go to a different one, see if it helps. Nope. So then I would go to our key terms. Doesn't have anything on a rotation. So since I didn't find one that I liked in this, and I didn't want to, I would actually use this Khan Academy Rigid Transformations 1 to go through it. But since I'm wanting to save a little bit of time, a rotation preserves distance and shape. So if a segment's rotated, that means that same segment has the same distance. So knowing that, I would write that down in my notes. So now I'm going to look at the proof. It says segment AB is a rotation of segment DE. That's given. Again, this is read. Distance of AB is equal to the distance of DE. That is because a rotation preserves distance. A rotation is an isometry, and isometries preserve distance. That is our reason. And then jumping down here, we have the measure of angle B is equal to the measure of angle E, the transitive property of equality. If you look up to this statement before, it had the measure of angle B is equal to 62.3. The measure of angle E is equal to 62.3. So they just cut out this 62.3. That's the transitive property. So now they can state that the angle B is congruent to angle E, because it's definition of congruent angles. So congruent angles have equal measures, which it does since they both equal 62.3 degrees. So that is how I would break down this proof, and you could copy it, take notes if you wanted on it so that you could refer back to it when you hit the checkpoint.